Hello, I am Vinita Navalkar and today I am going to tell you some interesting facts about planet Mars. It is the fourth planet in our solar system after Earth and one of the most explored planets by humans, apart from Moon of course, which is not a planet. So, not only after the advent of space age, but even before the advent of space age, people are very much curious about planet Mars. So, this, if you see this image, this is one of the first maps drawn of Mars, which was actually drawn by observing Mars through earth-based telescopes. Okay, it was an Italian astronomer who drew this particular map, and the interesting facts about this map is that what he thought was there are a lot of canals on Mars, okay, which looked more like made by artificial canals. Just as we have made canals on Earth, it looked as if there are canals on Mars. And that was pretty interesting for the astronomers at that point, because they thought that there must be some intelligent life staying on Mars and which has made these canals. Okay. Eventually, with the advent of space age, of course, we discovered that these canals are natural, and of course, there are not so many canals as drawn by him, but yeah, there have been riverbeds, there have been tracks of flowing water in the past. So, there are a lot of natural canals that are already existing on surface of the Mars. Okay, so, and these particular map actually created a lot of interest in humans that time, or astronomers that time, because it was really believed that intelligent life must be existing on Mars. So, these are few of the successful missions taken to Mars, and the list goes on and on. It's much more exhaustive than what I have shown here, but these are the successful missions. So, like, these are the missions, the probes that have successfully landed with rovers, and these are the probes which have been orbiters. So, of course, we got quite interesting data from each of these missions, and I will be telling you few of the interesting facts that we have come to know about Mars from each of these missions. So, the most interesting thing that we came to know, of course, mainly by extrapolation, is the tilt of Mars axis. So, we know the axis of Earth is tilted by 23.5 degrees, and that's how we have seasons, right? The tilt remains constant fairly in our lifetime, or for past few hundred years we have seen that the tilt remains constant. But if you consider time scales of 10 million years or so, then it has been estimated that the Earth's tilt varies between 22 degrees to 24.5 degrees. Okay, but in case of Mars, the variation has been huge. Okay, it has varied between 13 degrees to 40 degrees. That is an estimate. Of course, no one has lived long enough to actually go and measure how it has been, but this is an estimate that between the tilt of the Mars axis has varied between 13 to 14 degrees. Currently, it is 25.19 degrees, which is almost similar to Earth, and so the seasons on Mars are also similar to Earth, but just that a year on Mars is roughly twice that of Earth years. So, all the seasons are of double duration. So, if you have a particular season, say roughly of 4 months on Earth, on Mars it is going to be of 8 Earth months. So, the seasons over there are double, but more or less the seasons are similar. So, there is also another interesting fact or interesting conclusion that you can draw if you consider that the axial tilt varies between 30 degrees and 40 degrees, and that is, so supposedly let us consider right now that the axial tilt is 13 degrees. So, if the tilt is 13 degrees, the poles are facing away from the sun. So, what happens is the polar caps on Martian surface grows, okay, and it grows to almost the tropical regions. It grows for lower latitudes as well, and you have nearly 3/4 of the Martian surface covered with ice. Okay, now consider the fact that this particular tilt has shifted to 40 degrees, the another extreme. Now, what happens is the poles are nearly facing the sun. Okay, so all the ice melts and you do not have much ice left on Mars. Okay, so this drastic variation in the climate or ice on surface of the Mars also changes the seasons, or in general the climate, Martian climate, over a period of almost 10 million years or more so. Okay, so this has been estimated. There are also a few interesting observations we have seen with all the spacecrafts that we have sent there. So, most important observation is we have dry ice snow falling on Mars. Okay, so here we have snowfall in winters, and it's generally water ice. The snowfall that we get is water ice. But when you consider dry ice or carbon dioxide ice, generally requires very low temperatures for carbon dioxide to snow in a form of a dry ice. So of course, and that's what it has been observed by many spacecrafts. One was Mars Reconnaissance Orbiter, and of course Curiosity has also detected CO2 clouds on Martian surface, in Martian atmosphere basically. So now how are these clouds exactly formed? So generally we know on Earth we have water vapor being evaporated due to, of course, sun is the major source of evaporation, and then water reaches to a certain height, then it condenses back. Okay, so it requires certain temperature at a certain height known as hygropause. Okay, that height is called hygropause, where it reaches and then it condenses and falls back in a form of precipitation or rainfall. Okay, in case of dry ice, we require really low temperatures, and those low temperatures are achieved at much higher altitude. So generally, even on Mars, we see water ice clouds below 60 kilometers, but we see dry ice clouds above 60 kilometers. So that's where you achieve this lower temperature, and eventually the gas, the CO2 gas or the carbon dioxide gas forms into crystals and precipitates in the form of a snowfall. Okay, so that has been observed. This particular image has been taken of South Pole, Martian South Pole, where you can see this white patches here are basically the dry ice snowfall that has happened in those regions. Okay. These are some very interesting images that we got from Curiosity rovers. So these are the clouds which were photographed above 60 kilometers in height. These are the carbon dioxide clouds that eventually precipitate in the form of a dry ice snowfall. Okay. Also, now we saw that the temperatures above 60 kilometers are really cool, and we have carbon dioxide ice falling down as snow and so on. So we were just discussing about the atmosphere of the Mars. Coming to the surface of the Mars, as we have discussed before, we have seen a lot of canal-like structures or tracks of dried river beds on Mars, but we know that currently, the current observation says that there is no flowing water on the surface of the Mars. Okay, so but we also have a clear evidence that not only the pictographical evidence of dry river beds, but also clear evidence that chemical evidence that at one point there was water flowing, a liquid water flowing on surface of the Mars, and this we come to know from certain rocks or certain minerals, certain elements that are created and trapped in the rocks over there. For example, iron sulfate, which is something that can be formed only in a presence of liquid water. You require those conditions, but we have seen presence of iron sulfate in some of the rocks on Martian surface, which says that if this has been, iron sulfate has been present in a rock, that means there was flowing water once upon a time. Not only that, so Opportunities rover has also seen, have photographed certain rocks at the bottom of Endurance crater, one of the craters on Martian surface, which shows that there has been flowing water before the crater was formed. The crater is an impact crater, so obviously it has been formed by some meteorite impact. So there was flowing water before the impact, there was flowing water even after the impact. So the images and the study definitely shows that there was a lot of flowing water on the surface of the Mars at one point of time. This is a current map that has been created of all the observations that we have got. So which shows that how much water is present, not on the surface but subsurface. So this reddish regions that you see here are the maximum concentration, okay, by mass, it has been shown. So we have H2O, or rather this map actually is not directly detecting H2O but presence of hydrogen. Okay, so if there is a presence of hydrogen, we know there might be possibility of having water at those regions. So these red regions are where hydrogen is being found abundant, and blue regions are where the hydrogen is minimum. So as we can see, roughly above and below 60-degree latitude, the concentration of hydrogen is maximum on surface of the Mars. So near the poles, it is possible that subsurface water might be existing even now. And these are some interesting photographs about the river beds I have been talking about. So these are the dried river beds. We have these images very similar to that we have on Earth. Once we see any river dries up in summer, we see these type of marks on surface of the Earth as well. So similar marks have been seen on Martian surface, where it clearly shows that okay, water has been flowing through these and eventually it has dried up now. This particular particular rock has been smoothened out because of the Martian water flowing at one point of time. You can see that, and here you can see the islands being carved out of flowing water. So these are the islands and maybe the water tracks have been in some direction like this. So these particular island like structures have been carved out of, might be some flash floods happening at that time on Mars. So these type of island structures have been carved out. So these interesting features are seen throughout the surface of the Mars, which clearly shows that there has been flowing water at one point of time. Okay, now when we say there has been flowing water at one point of time, where did the water go? Okay, there has to be some mechanism by which the water goes away from the surface. One, of course, we know is by evaporation. We have seen that on Earth also, but as I said previously, once the water is evaporated in a form of a water vapor, it comes back down as precipitation after it attains certain height and it reaches lower temperatures. Now in case of Mars, we know that after 60 kilometers the temperatures are so low that carbon dioxide precipitates, but at the same time the gravitational force of Mars is so low that whenever the water vapor rises, the gravitational force is not able to hold it down. Okay, so the water vapor escapes. Okay, also as we have seen that temperatures on Mars vary depending upon its tilt, and also there is another reason why the temperatures on Mars vary drastically. One is its eccentricity. Okay, for Earth we have nearly circular orbit, but Mars has second largest eccentricity in terms of orbit. Its orbit is highly elliptical after Mercury, and because of that sometimes it is very much closer to Sun, sometimes it is quite farther away from Sun. Now this also gives higher temperature variations. Okay, so now if water vapor evaporates, say consider that it's summer over there, water vapor evaporates, due to low gravity it is going to escape out in space, so that water vapor is lost. But there is also another possibility. So when we consider a hygropause level, we consider that okay, there is a certain temperature that it reaches and it precipitates back. Okay, but what if the temperature is high enough and water vapor is not condensed into water, it will not precipitate back. Okay, so it is quite possible that in summers, in extreme conditions, this hygropause level at Mars does not really attain the temperature for water to precipitate back into liquid form. Okay, and so in that case also the water vapor can escape. Some other mechanism has also been observed on Mars, and that is the huge dust storms. Okay, so many of the missions, even the current Perseverance mission has recorded lot of these type of dust storms. There are many dust storms continuously going on the surface of the Mars, obviously because it's a dry condition out there. Now these dust storms also churn out water vapor from the surface of the Mars, let it escape to the space. Okay, so that has been one of the factors where water must have escaped. This is also an image taken by one of the rovers on the surface of the Mars, which is showing a huge dust storm covering the surface of the Mars. Okay, this is one of the recent images taken of the dust storm by NASA's Perseverance rover. Okay, so you will be able to see a dust storm rising here in the hilly region and moving across. So this, as I said, this has been a frequent phenomenon on the surface of the Mars, and eventually this might be one of the mechanisms to for the water vapor to escape the surface. Okay. Another hypothesis why water must have been lost from the surface of the Mars, as we know that Martian gravity is very low. At the same time, throughout our solar system, we have solar winds bombarding on the surface of every planet basically, and also we know that Martian atmosphere is very thin. Okay, so if you see this particular image, you can see at one point of time Mars must have been covered with lot of water, surface water, but eventually as the solar winds bombard and its atmosphere also becomes thinner and thinner due to low gravity, eventually whatever water was present on the surface has eventually evaporated, and now Mars has become dry, totally dry, and if there is any presence of water on Mars, then it must be definitely subsurface. Coming to the in general geology of Mars, then we have the core primarily consisting of iron and nickel, about 16 to 17% of sulfur is also present. It is surrounded by, of course, a silicate mantle and a crust which is abundant iron, which of course gives its red color. That's how it is called, the red planet. And of course a few traces of magnesium, aluminum, calcium, potassium are also present on the surface. None of the space missions have carried the soil back to the Earth so far, yet we do have some Martian rocks found on Earth. There were few rocks found in Antarctica, there were few rocks found in Egypt. So these generally what happens is if there is any meteorite impact on the surface of Mars, then thanks to its low gravity, some of the rocks are ejected, and over millions of years eventually they crash on the earth as meteorites. So people have studied this, scientists have studied these rocks, and eventually they have deduced that these rocks are from the Mars. Now how have we done this? So whenever the rocks are ejected due to impact from the surface of the Mars, there are Martian air bubbles, whatever atmosphere is, thin atmosphere is present around Mars, those bubbles are trapped into these rocks. So studied here, where these rocks are actually broken into pieces, they are melted in acids sometimes, and that's where people can match the content of these bubbles is same as the atmosphere on the surface of the Mars. So that's how it has been deduced that these rocks have come from the surface of the Mars. So I have some images here. This was one of the fragment that was found in Antarctica in 1984. This is one of the oldest meteorite that we have found in Egypt. Now this has been broken into pieces to see what is the inner structure of this particular meteorites. These are the images of the meteorites that we have received from Mars. This one has been found in Antarctica in 1984, and this is one of the oldest meteorite, Martian meteorite, that we have found. So this was actually found around 1901, 1902, but it was studied, it was broken into pieces in 1998 and studied in detail, deduced that this particular meteorites have come from the surface of the Mars. Okay. So there are some very interesting features found on the surface of the Mars, and one of them is of course the largest mountain, that is Olympus Mons. It is so huge that if you see the entire state of Arizona, one of the largest states in USA, it's almost the size of Arizona state, which, if to give you a comparison, this particular state is bigger than the distance between Mumbai and Ahmedabad. So it's that huge, and it is considered to be the largest mountain in our entire solar system. So if you consider all the terrestrial planets, then whatever mountainous regions we have, it is considered to be the largest mountain in our solar system. So to give you a comparison about all the mountains on the earth and Olympus Mons, you can see Ben Nevis, which is in Scotland, which is considered to be the shortest the mountain, and Mount Everest, which is considered to be the tallest mountain. So in comparison to both of this, you can see Olympus Mons is huge in diameter as well as in height. Okay, so it's one of the largest mountains that we have seen, and it is also volcanic. So there is also another interesting feature, and that is Vallis Marineris. It is a great canyon-like structure on the surface of the Mars, and it is so huge that at times you can, whenever Mars is closer to Earth, you can also actually see this particular feature right from the Earth with, of course, some bigger telescopes. So again, to give you a comparison, so if you consider the diameter of the Mars, it's almost half the size of the Earth. So roughly 6,600 kilometers is the diameter of the Mars, and this particular Vallis Marineris is almost 4,400 kilometers. So it's almost occupying 2/3 of the Martian surface. It's a huge, rich or a huge canyon-like structure, mainly carved out of one-time flowing water or even some tectonic movements. Okay, so it's a huge feature that we see, and just to give you a comparison, if this is the entire surface of the Mars, it is almost occupying 2/3 of its surface. So this is one of the closest image of Martian soil or Martian grains, sand grains, that we have got from a recent mission, Perseverance, which was launched by NASA in 2021, and it is a rover and also has helicopter or drone as they call it. It is called Ingenuity, and it has photographed one of the closest images where you can actually see a single grain of the soil on the surface of the Mars. These are series of photographs taken by Perseverance.